We are going to go over today some of the things that we didn't quite get to in 3.6 in geometry on Monday. The first thing I wanted to start with is something we actually did cover, but I want to make sure that you get it into your notes because it's not part of your notes. So that is Theorem 3.11 and 3.12, which I have up on my screen here. Let's see if it'll let me make these a little bigger. Oh, nope, just the size of that. So let's just review these two. Again, they're not going to be in your chapter 3 notes, but you should put these into your theorem notes that you have. Okay, so the two theorems are 3.11, which is the perpendicular transversal theorem. Okay, so we spent a lot of time in the beginning of the chapter talking about transversals and the relationships between the angles. And this is a specific kind where the two lines that are being cut by the transverse line, that line is going to be perpendicular to one of the two lines. Okay, so basically what we have here is we have that line H and line K, H and K right here. Oops. We've got H and we've got K, and they are parallel to each other. It's indicated by those little triangles there, right? And we know that line J is perpendicular to line H. So this theorem says that, well, if J is perpendicular to H, then J should also be perpendicular to K. So you see it written right here, perpendicular, and J should be perpendicular to K. And this shouldn't be too much of a surprise because back in the beginning of this chapter, right, these would be considered corresponding angles. And we proved, well, actually we have a postulate that proves that corresponding angles are equal. So those two angles would be equal, and that would mean that they are perpendicular. So K and J are perpendicular. Okay, and the other theorem, 3.12, kind of takes a flip off of that, kind of the reverse. So this one says, okay, well, we know that M is perpendicular to P and N is perpendicular to P. So if M is perpendicular to P and N is perpendicular to P, these are both perpendicular, then we know that the two lines are parallel to each other. So this is a little bit of a different take on the same kind of concept. We know that both of these lines are perpendicular to P, which would make them parallel to each other. Okay, so just make sure you've got those in your theorem information packet. So what I wanted to do is give you a few examples since we didn't do any in class, and I have a few up here. Let's see, which one do we want to do first? Let's do this one first, okay? So it says, determine which lines, if any, must be parallel in the diagram and explain why you think that, okay? So, so we're going to try to figure out which lines are parallel to each other. If I can get my marker to work, there we go. Which lines are parallel to each other, and we're going to use our thinking. Okay, so the first thing is we're going to use those theorems that we just talked about. So the first thing I notice is that right here we have that X is perpendicular to R and Y is perpendicular to R. Okay, so X and Y are both perpendicular to R. So by theorem 312, the second theorem we just talked about, right? Theorem 312. Oh, I'm going to get my pen out here. By theorem 312, we could say that since X is perpendicular to R and Y is perpendicular to R, that means that X is parallel to Y. Okay. And then we also notice we've got another one going on here. We've got, let me switch up colors a little bit. We've got that line R is perpendicular to line X, and line S is perpendicular to line X. So let me write that down. We've got line R is perpendicular to X, and we've got line S is perpendicular to X. So since those are both perpendicular to X, we can say that R is parallel to S. This is, again, by that 3.12, the second theorem that we just went over. Okay, so now let's I've got all kinds of lines on here. So we've got those two down. Now let's look at lines X and Z. So switch colors once again. We've got X is perpendicular to S, and Z is perpendicular to S. So we have X is perpendicular to S, and Z is perpendicular to S. And again, by theorem 312, if we have two lines that are perpendicular to the transversal, that means that those two lines are parallel to each other. So we use 312 many, many different ways, right? So let's see if there's any other relationships we have based off of theorem 311. And that is, if we look at all of these relationships that we've found so far, we have X is parallel to Y, X is parallel to Z, and R is parallel to S. Well, we can use the transitive property of parallel lines with these two right here. So remember, transitive property is if X, X equals Y and Y equals Z, then X equals Z. Well, we have X is parallel to Z, and we have X is parallel to Y. So that can lead us to Y is parallel to Z. So those are the four relationships we have. So basically what we're saying is that X, Y, and Z are all parallel to each other, right? And we know that R and S are both parallel to each other. We have a lot of parallel lines there, right? So let's do two more examples just to make sure that it makes sense. Here's another diagram that shows some lines. None of them are shown as parallel, but we have some perpendicular angles, right? So the first question is C parallel to D? So this one is actually a pretty easy one because it's pretty much the definition of theorem 3.12, okay? Because C is perpendicular to A. So see right here, C is perpendicular to A. Let me turn my brush on. C is perpendicular to A. And D is perpendicular to A. That means that we can use theorem 3.12. So that says that since C is perpendicular to A and D is perpendicular to A, that makes C parallel to D by theorem 3.12. Okay. Now the next question is a little bit trickier. It says, is B perpendicular to D? So we're talking about right here, this angle. Is this perpendicular, and can we prove that? Okay, well, there's no indication or marking on there if B and D are perpendicular to each other, but we can use our other information that we have to figure this out. What we do know so far is we know that C is perpendicular to B, and we also know that C is parallel to D. And because C is perpendicular to D and C is parallel to D, we can actually use theorem 311, the one before that, right? That says if we have if two lines are parallel and one is perpendicular to that line, then the other is perpendicular. So by theorem 311, we can say that B is perpendicular to D. All right, and that is all the examples I have for you. I will be online on Friday at 11 if you have any questions, and hope you guys have a great week. Thanks. Bye.